also one from China is also there.
Nice. He's a lead on Titan.
Yeah.
For Amsterdam.
We are online. No, it should change shortly.
Yeah.
Okay. We are online on the right link without audio yet. So.
Hello, welcome to this Retrieval Markets Workshop, Intro to Saturn. We've got a great schedule lined up today. In the first block, we've got myself giving a presentation just to introduce today, and Juan Bennett, the founder and CEO of Protocol Labs, speaking about the wider vision and introducing the day too. There's been a slight change to the schedule in so much as I'm going to be starting off and Juan's going to be going next. Following a break, we'll then move on to two of the engineers working on the Saturn project to introduce it in more depth and go through some more of the technical details. In terms of the flavor of today, it's going to be quite a technical and architectural look at Saturn rather than anything sort of more product focused. And then, for anyone who's here in person, we've also got the added bonus of a workshop after the live stream's finished. So thanks for showing up in person. And with that, I will begin. So, Retrieval Markets Workshop, Intro to Saturn. I'm going to start off with a motivation of why we're talking about retrieval here at all. A lot of the events of Protocol Labs are focused around storage, but retrieval, in my opinion, is equally as important. So we'll look into why that is. We'll then talk about what a retrieval market is. These words are used in the title of today's workshop, but it's good just to get that definition sorted. We'll then look at the Filecoin retrieval market, why we need a Web3 retrieval market in the first place, and then I'll talk a bit about the Retrieval Market Working Group, which is a group of teams who are all working in this space. Okay, so some motivation. This statistic is taken from the cloud industry, and it goes that by 2025, the global content delivery network market is expected to be twice as large as the cloud object storage market. So for CDNs, think Akamai, Fastly, Cloudflare, CloudFront. For cloud object storage, think AWS S3. So we're saying that actually fetching your file from cloud services is a market twice as large as storing them in the first place. When I first saw this kind of surprised me. I kind of felt that whenever I stored stuff in cloud storage, the acceleration of that content in a CDN was like an added extra benefit. But actually, when you think about it some more, it starts to make a bit more sense, because people around the world using their browsers, using games, and more recently interacting with metaverses, they expect an incredibly good experience when they're retrieving files from storage providers, and they expect things to load almost instantly. if you think about how quickly you get results from the internet, it's actually mind-blowing that you can load a list of pages, which when you do a Google search, for example, you can load a list of pages quicker than it takes for you to actually search your own computer for files. It's so optimized. And so people expect this great experience, and as such, content providers are happy to spend a lot of money on creating such a good experience for their clients. And that's why this retrieval space, these retrieval networks, there's actually such a big market. And I think what's super interesting here is actually in the Web3 space, it's more of an untapped market. We speak a lot about storage, but I think there's still lots of ground to be fought over in the retrieval space. So yeah, we're talking about retrievals today. That's essentially what I was getting at there. Now we're going to talk about what a retrieval market is. So these two words we use a lot in my work, and I just want to make sure that we're all on the same page as to what we're talking about. So what is a retrieval market? To me, it's a setting or a place where individuals, entities, nodes can contribute their resources in order to provide data retrievals to people who are demanding that data. And trying to optimize the experience for people who are demanding the data. So that means we're looking at good performance, good reliability, and economic retrievals of data. Now, I think the CDN providers that I spoke about previously, Akamai, Cloudflare, CloudFront, etc., they operate in a retrieval market. And that's the sort of Web2 retrieval market, as we'll refer to it. But in particular, in the Retrieval Market Working Group and at Protocol Labs, we focus on decentralized retrieval markets. And that adds a lot of extra interesting complexities. So the Filecoin retrieval market, as I'm saying, is a setting where we can see an emergence of these content delivery networks. And the Filecoin retrieval market is the emergence of a decentralized content delivery network around the Filecoin storage network. But we could also speak about this a bit more generally and say we're looking into decentralized retrieval markets around content-addressed data. And we'll go into more detail about why the data has to be content-addressed in this decentralized setting. So yeah, when we zoom in a bit and think about it a bit more, like, okay, what actually are the building blocks of a decentralized retrieval market? We start to come up with these different topics we can look into. On the right-hand side here, we've got this research to development scale, this pipeline of how developed this particular topic is. So I've tried to match each one of these building blocks on the left-hand side onto this scale. And I'm just going to quickly rattle through them. So cryptoeconomics, we need to find ways in which nodes are going to join a retrieval market, or they'll be incentivized to join the network because of the rewards they're going to get for providing a service. And we also have to think about making sure the cryptoeconomics are aligned with the goals of the network. And the goals of the network here are to provide those fast retrievals. And it can often be quite challenging to completely align the cryptoeconomics with the actual goals of a network. The second point is retrieval mining. So this is sort of a sub-branch of cryptoeconomics and more of a research focus. But are there ways in which we can have block rewards where we can reward these retrieval providers based on the services they provide in sort of a probabilistic way, or like more of a lottery-style approach? Payment channels. So again, we've got to keep reminding ourselves that this is a decentralized network. If I'm going to be serving a retrieval, I want to earn for it. And either that can happen from block rewards from a blockchain, or it could happen in payment channels that are managing off-chain payments, which could then be later resolved on an on-chain network, on-chain blockchain. Reputation systems. We're in a trustless setting, so I don't know who I'm talking to. So it'd be great for me to understand each node. Are they actually trustworthy? Have they been serving good retrievals for a long period of time? Is this someone I want to do business with? Indexing. So can I find data very quickly? Are there services in the network which are going to allow me to find data quickly? And then there's content indexing, where I could use search terms to try and find data just based on those words. So essentially Google search for Web3. We look at data transport and transfer protocols. So how can we improve BitSwap, which is the main protocol for IPFS, and GraphSync, the main protocol for Filecoin? And how can we also add other data transport and transfer protocols? For example, HTTP, which can allow us more access into browser retrievals, moving on to point 7, or perhaps other more interesting protocols like WebRTC. There's some research going into that at the moment, which we'll come to later. And then finally, network monitoring. Network monitoring, we want to understand how these networks are performing. We want to see where the bottlenecks are, where people are emerging to provide a retrieval service, and where perhaps there are gaps in the offering. Cool, so now I'm going to move on to the Filecoin retrieval market in particular, and just talk through the different parts of the Filecoin retrieval market so far. So in this diagram, on the left-hand side, we've got a retrieval client who is going to be trying to retrieve a file from a Filecoin storage provider, which is in green on the right-hand side. And we call this the primary retrieval market. The primary retrieval market means that this is a deal and a transfer that's happening against a Filecoin storage provider rather than any sort of secondary caches or retrieval providers. And as of the time of Filecoin launch, this was the approach that the retrieval client would have to go through in order to make a retrieval. If it was a retrieval that they wanted to pay for, they would have to start off by setting up a payment channel, which is an on-chain transaction. They would then transfer vouchers to the storage provider in exchange for bytes in this optimistic fair exchange protocol. So the client would send one voucher in exchange for 1 byte. Then it would say, okay, this is working. I've built a little bit of trust in this storage provider, so I'm going to send a few more vouchers, and so let's say 2 vouchers for 2 bytes. And you build up more vouchers for more bytes until the end of the file. And the reason it's an optimistic exchange is because at any point the storage provider could decide not to send the bytes, and at that point the retrieval client has no way to sort of register a dispute. It just doesn't get those bytes, and so it's relying on sort of implicit trust in the storage provider to send back those bytes. Once the whole file has been sent, the storage provider can then redeem the vouchers that it's retrieved for some Filecoin, again an on-chain transaction in the payment channel. Now, why are we using vouchers rather than just Filecoin transactions? The reason is we don't want to have to wait for an on-chain transaction every time we want to receive some bytes. We need this to be very, very quick. And so we've got this off-chain setting where we can exchange vouchers for bytes. In all of this, we've got quite a lot of requirements we're placing on the retrieval client. So it's not really, a browser couldn't really sit in this blue box because it wouldn't be able to make that on-chain transaction for a payment channel or do this graph sync style protocol to exchange vouchers for bytes. And so there's quite a lot of heavy requirements on the retrieval client. Another thing to mention is storage providers aren't really equipped to deal with lots and lots of retrievals. Like Web3 CDNs, they deal with DDoS attacks and also spikes in traffic. And storage providers aren't really equipped to deal with that. So a steady stream of traffic is okay, but not the sort of spikes we see in the internet today. So yeah, as I say, that was the last slide was how Filecoin launched. And now what we're starting to see emerge is what I've tried to capture in this diagram. So we have content publishers down in the bottom left who are now speaking to what I've called deal and distribution services. For example, Estuary. So they say to Estuary, we'd like to store this data and we'd also like it to be retrievable. And the deal and distribution service, for example, Estuary, makes storage deals with one or more storage providers and then also allows an IPFS retrieval story through the IPFS gateway. So this is great. We've got some archival storage covered with Filecoin, and we've also got an IPFS retrieval story. However, I suppose it leaves a few things to be desired in terms of sort of the decentralization, the Web3-ness, and also the cryptoeconomics of the system. What we'd really like to see is for the storage and the retrieval story to be linked, and so we can have a way that value can flow between those two parts of the architecture. If we think about the sort of Web2 value flow, it would be from the content publishers to the website or web app providers, and then they would serve to those clients, and perhaps the clients would provide value back to the content publishers by buying things or interacting with marketplaces, that sort of thing. And we've got a similar sort of thing where that can happen here, where the content publishers are transferring tokens or value to the deal and distribution service, which then goes to storage providers. But it doesn't really link up to the IPFS story here, we've still got people providing IPFS nodes without sort of the incentive to do so, and the person who's providing the IPFS gateway is picking up the bill here to provide the retrievals. And then what we're starting to see emerge on top of the previous diagram are these content delivery networks, which are essentially cache missing to the IPFS gateway. So to mention a few, we've got NFT.storage gateway, which is racing IPFS gateways on a cache miss, and then is populating the cache with the content. We've got Meson Network, who's building a decentralized CDN, which cache misses to the IPFS gateway, and the Media Network, which is also cache missing to the IPFS gateway, but the actual CDN is more decentralized. I think this is really interesting because it's latching on to the current retrieval story, but we're still not connecting it back to the original storage story. So that takes us now on to the secondary retrieval market, which I've still got the content publishers down in the bottom left and the deal and distribution service, and they're still talking to the storage providers. But I've replaced the IPFS retrieval story with this ring of retrieval providers and also index providers. The idea here, and why it's a secondary retrieval market, is that the retrieval providers, so the primary retrieval market, if you remember, was talking to the storage providers and making deals and transfers with the green nodes in this network. The secondary retrieval market is where retrieval providers could talk to each other and make deals and retrievals with each other, and it sort of distances it from the storage providers. One of the roles of these retrieval providers, similar to the IPFS gateways, is we've now got a translation layer between the clients that we use every day, like browsers, game consoles, and as I say, metaverses coming soon, to the graph sync protocol and the ways that we can talk to storage providers. So we've got this sort of translation layer. We've also got this indexer provider coming into the architecture here. This is work that was recently carried out by the data systems team on the indexer node, and that can help to inform the retrieval provider how to make a quick retrieval from storage providers in the primary retrieval market. And we can also see now that the retrieval providers could then act and fulfill the same roles as Web3 CDNs, so they can start to handle traffic spikes and other sort of attacks on the sort of front line of the internet. Another thing to mention is this can now allow us to have much lower hardware requirements for someone to contribute to the network. To be a Filecoin storage provider, you have to have a pretty beefy node, and there's some barriers to entry in terms of the hardware you need to have. Whereas retrieval providers, if we can allow anyone to join with old devices or their current desktops and laptops, we can start to enable anyone to join the network and provide value to the network. So as I mentioned on the last slide, we've got these CDNs that are cache missing to the IPFS gateway. We've now got these, we're going to mention a few other networks which are emerging more towards this architecture, and I've written them down here in order of when they sort of started working in this space. We've got the MyL network, we've got Saturn, and we've got Titan. And we'll be hearing, as I say, from the Saturn team a bit later. I think also Titan is a moon of Saturn, which is interesting that we've got two Saturn-based planetary teams. I don't think MyL is related. I think it's to do with like something in your brain, but I'm not entirely sure where that name comes from. Okay, so I've tried to map out all of these different networks I've mentioned so far that are emerging in this space. Quite crudely onto this Web2 to Web3 axis. So firstly, a disclaimer that I apologize if anyone who's watching live or here in person disagrees quite with the placement on this axis. But I think it sort of captures the point that there are trade-offs that you have to make in order to talk to the clients we use every day, like browsers, and that trade-offs that make you more Web2 focused. And then there are teams like MyL who are working on the no trade-off approach where everything is pure Web3. But it makes it, I guess, a little bit more difficult to integrate with everyday devices and to manage the network and apply the cryptoeconomic mechanisms which are starting to form. Okay, why do we even need a Web3 retrieval market? So I guess the first answer to that question is just because it's Web3. If we have a Web3 stack and it then has a Web2 part of it, then for a lot of people that just kind of breaks the whole chain, and you're only as good as your weakest link. But the Web2 offerings like Cloudflare, etc., they offer a pretty good service. For very small files, it's very performant, it's reliable, and it's pretty economic. So why is it we want to reach for a Web3 CDN and delivery network? So I've got at the top these features or requirements. And these are things I think that any Web3 CDN has really got to focus on. And I believe from these features and requirements, we get the value propositions below. So firstly, it's got to be permissionless. Anyone can join. Anyone can start to contribute to the network. And that sort of also links to this lightweight devices can join. If lightweight devices can join, then anyone can join. And you allow the network to be sort of market-oriented and just anyone can be part of it. And I think that's really important. It's got to be content addressed, though, because if you're retrieving files from a node that you don't trust or has just joined the network, if you ask for a very large file and they just return you a tiny file or just the wrong file, you need a way to sort of check that what you've got back from them is what you asked for. And that's where we lean on content addressing, as we do so often in IPFS and Filecoin networks. It just really wouldn't work with location addressing because you just wouldn't know what you get back is the right thing. And that also links back to here. One of the key things that makes one of these networks more towards the Web3 scale is the verifiability. When we're fetching things from the IPFS gateway as a raw file, we're not verifying that it's the right file. We're implicitly trusting those gateways to give us back the right file. And as we move more towards the Web3 end of the axis, we're not so much trusting those nodes, and we're having to verify those files. But that means that, let's say we're in a browser, that's an added thing the browser's got to do, which it doesn't normally do to the files it retrieves. And crypto-incentivized. There have been peer-to-peer networks for retrieval in the past that have had great success. There have been some now which are starting to launch with crypto incentives. I think that's an important part of creating an economy which will thrive and continue for a long time. And the value propositions this gives us, as I've already sort of mentioned, conflating it a bit with the requirements, is the low barrier to entry. Anyone can join. I then think one of the 0 to 1 innovations of the Web3 CDN is that users can earn. In the Web2 context, it's quite an asymmetric relationship. We just retrieve from these CDNs, we get the files, but if they go down, then we can't retrieve, and there's nothing we can really do with those files once we've retrieved them, apart from just view them. But in this Web3 context, you could retrieve, and then you could start to earn by sharing what you've retrieved with others. So it's enabling users to earn by being more symmetric and more powerful nodes in the network. We can get multi-peer retrievals, something which the BitTorrent networks did previously, but we can start to, rather than just always fetch from that one point of presence, we can start to get parts of the file from different nodes. And that links to sort of network resilience a point further down. If nodes start to go offline, we can start to fetch files from different parts of the network. Deduplication, because it's content addressed, we don't have to store the same file again and again just for different content publishers. We know that it's just a particular block or a particular file. We can store it once, even if many different clients want to retrieve it, or many different content publishers want to store that same file. So it's just kind of a nice optimization. And then it's market-oriented. If we start to see spikes in particular parts of the world, or even in sparsely populated regions that are far away from current points of presence in Web2 cloud providers, then we can start to see people spin up their nodes there and provide a good retrieval service. And finally, it's economic for large files. So I would say that's an area which there's a lot of untapped potential, is videos, large NFT media files, metaverse files. We could start to see really interesting solutions for how we can quickly and performantly get those files into each peer in the network. Okay, and finally, I'm going to talk about the Retrieval Market Working Group. So I brought back in the different building blocks of topics that we touched on earlier, which we're looking at as part of a retrieval market. And going through some of the teams that we've got working in this space, and I'll just very quickly introduce what they're working on. First, and also I'd like to apologize here if I haven't got a particular team down. Just apologize in advance. I think I've covered most of them though. Magmo, this is a team which is part of Consensus, and they're working on multi-hop payment channels. So how can we, rather than having a payment channel in between each retrieval provider and storage provider, can we have sort of a payment channel manager or payment channel provider that can start to match retrieval providers with storage providers and allow this to happen in a performant way? Top right, we have Ken Labs, who are working on reputation systems, in particular this metadata service called Pando, and they're just about to start the second phase of that. We have Mael, who are working, as I've mentioned already, on a retrieval network. They've also done some great stuff with browser retrievals and looking into that, and also looking at GraphSync and how we can write it in different languages and make improvements. So that folds into sort of data transport and transfer protocols. ChainSafe, they've been working on content indexing. So, as I mentioned, how do we build a Google search, but for Web3? And they've also been looking at WebRTC data transport. Leeway Hertz, they've been working on network monitoring. How can we figure out how fast it is time to first byte or time to last byte across all of these different retrieval networks and find ways we can improve the networks. And finally, New Web Group, who are building the Titan network, where they want to leverage all of the unused bandwidth in home networks in order to create a thriving retrieval network. And we have currently 10 plus grants in progress, lots of teams working in this space. And if there's any other teams listening or interested, just get in touch and we can start working on grant proposals. So yeah, get involved. If anyone's interested in learning more, head to retrieval.market or scan this QR code here to get there on your phone. Or just reach out on Filecoin Slack, Retrieval Market channel, and we can speak more about it. So yeah, many thanks. And I think there are 5 minutes for any questions, either from the stream, if you write it on the YouTube channel, or from us here in person. One question from YouTube? No. Ben, did you have one?
Yes. You had a slide about...
Hang on.
You had a slide where you explained primary and secondary retrieval markets. What exactly is the difference there? Like, how do they differ? And
yeah, let me just get back to the slides. Okay, so actually I think it's better to describe it on this slide. Can you see my mouse on there? Yes. So the primary retrieval market is where we can fetch stuff, retrieve stuff from the Filecoin storage providers. That's like the first layer of retrieval. But the secondary retrieval market is when we can fetch things, retrieve things from these sort of secondary cache layers. So that's the retrieval provider talking to a retrieval provider. And that's where we have the secondary market. Does that make sense? Cool. Any other questions? Nice. In which case, I'll wrap up this talk. Up next, we have Juan, who is going to talk to us more generally about retrieval markets and kind of wider vision. I think that will start in 4 minutes' time. Cool. So yeah, if anyone's online, just stretch your legs and we'll be back in 4 minutes' time.
Cool. All right, great. All right, everyone. Great to be here with you. I want to thanks for everyone for gathering, and great to be convening the Retrieval Markets workshop. What I want to talk about today is these four things. So just quickly touch on the Retrieval Markets working group and the workshop. Patrick already gave a phenomenal intro to the Retrieval Markets problem and the working group and so on. I want to focus most of the time on this rapid-fire updates across the ecosystem that can help all retrieval market groups integrate some of the information that's happening. So there's a ton of progress across the ecosystem on many kind of fronts. This will be useful for the people actually building the tech to be able to kind of tune their approaches based on the other opportunities that are happening in the landscape. And then from that, I want to then kind of have an open discussion about the retrieval markets landscape in 2022 and various different opportunities. And from that, narrow down to some set of network goals. So the last two sections will be more conversational. So want questions and so on from the group here or on YouTube and so on. And then from that, I want to kind of like propose a very concrete network goal that we should hit basically as fast as possible to kind of unblock a bunch of the kind of open-ended innovation that I think many other groups in the ecosystem have gotten to. Great. So kind of in short, the objective of the Filecoin Retrieval Market is to build the world's best CDN leveraging Web3 tech. So it's not about just building the best CDN in the Web3 world. We want to really build the world's best CDN leveraging the Web3 tech underneath the hood. So we can leverage content addressing, crypto incentives, verifiability, permissionless networks, and markets to build a massive scale cloud CDN that should compete and beat decentralized providers. Kind of a shorter version, a kind of like intermediate target building towards that is to build a worldwide fast and efficient CDN for IPFS content. So you can use that as a stepping stone on the way to building the world's best CDN. And so if we focus on the second goal as an intermediary goal, we can get to the first. There's been a working group effort around building the retrieval markets for a while. I won't go into in depth there because Patrick already did a phenomenal job giving us an overview. I want to kind of point out a set of goals that I think we should be aiming for. We should be aiming for a network of about 10,000 plus devices at minimum, so that ideally hundreds of thousands and millions. But just getting a network up of tens of thousands of nodes would already greatly improve the setup. Then from there, getting to thousands of people, thousands of individuals involved in retrieval mining. If we can get to that as fast as possible, so say in a quarter or two, that would be that would kind of unblock a lot of the innovation. And then if we can establish less than 1 second on average for delivery of any CID across all content, that would be transformative to the whole IPFS network and the Filecoin network. So right now, retrieval is a big bottleneck for a lot of use cases, as I'll go in detail in a moment. And so if we can just get to the point where for most retrieval queries for any CID worldwide, users can get a less than 1 second retrieval, that would open massive amount of adoption for all of IPFS and all of Filecoin and other networks, and then very market into something really big, and help Filecoin and the broader IPFS network achieve a lot of goals. So let's start with like a very, very concrete problem space of not 10,000 nodes is not that large of a network. We can totally do that. 1,000 people plus, not that hard. We can totally do that. Less than 1 second of delivery for CIDs worldwide. That's harder, but we can do it if we can focus on the things that are requested the most. And I claim that there's probably somewhere between 1 to 10 petabytes of hot content. That's what we need to distribute. Great. So this workshop has just an introduction to the retrieval markets in general. Then we'll have a section talking about Filecoin Saturn, and we'll hear from one project. And then we'll have an open discussion, especially around cryptoecon and various different approaches. So there's a lot of content already about kind of like why retrieval markets in general. There's a set of videos that you can look at on YouTube. There's a Filecoin.io explainer. And there's awesome content being produced through the Retrieval Market Builder demo days, you can go look at those and see all kinds of progress across the network. There's also a bunch of really good YouTube videos. In short, the kind of like the crisp view of this is that the internet is a grapevine. Content must flow through these very crowded branches to the leaves. And you want to create open-ended protocols that enables any participant around the internet to spot an opportunity to deliver content, leverage content addressing, and provide the best possible delivery of that content. The centralized cloud already kind of does this a bit with large storage networks and CDNs. But you can do way better if you make it open and permissionless. Right now, all kinds of groups that are in a great position to add a content cache very close to users and where the user demand is can't do it because there are all these private networks that are centralized and prevent their participation. So think of being an ISP or even like a cell tower operator or something like that. And there's all kinds of traffic flowing through that network, oftentimes the same kind of content, the same movies and so on. You could totally deploy a content cache right there to provide content to the users. But you really need the content flow to move into a content-addressed model of the world. And you need to be able to join a network that lets you kind of participate in that way. So that's why the Filecoin Retrieval Market can greatly speed up the CDNs of the world. The way to sort of like map storage providers and retrieval providers to the traditional cloud is to kind of think of this sort of layout where you have storage providers in the center, and then you have retrieval providers sort of as a cloud around them, which, as you'll hear from Saturn, like maps well to why the project name is that and so on. You should think of storage providers as coming in many different scales, from just a few set of drives and so on in a home to kind of like small racks to very large operations with full data centers. And we already see this across the network. There's massive scale storage providers with, and there's also a ton of smaller scale storage providers. So the data is finding its way to really great homes across this network. Now we need to build out the retrieval provider network. This will tune better for smaller devices and smaller deployments that are much more evenly distributed around the world, close to where people want to retrieve the data. I would add this is not in the explainer, I need to add an image for a mobile device. I think that mobile networks can also be good for retrieval, but it's actually a much harder problem. So I would not encourage groups to kind of start with that because getting retrieval CDNs and so on in mobile is way harder. But if you sort of target like home machines and maybe one single machine in a data center, or potentially like a full rack, that's about the size of what retrieval providers that I think will be really successful. The smaller home machines, of course, will be way more of them, and that will be kind of extremely useful to store data. Less so to serve data at really fast speeds. Smaller deployments sprinkled in internet interconnects. So there's all kinds of data centers that are where there are kind of terminals where lots of different cables and so on and different organizations peer with each other. Those are great spots for one of these like larger caches that can do a lot of has a lot of bandwidth capabilities, or ISPs. So any kind of like either hardwired ISP or a wireless ISP. Those are great places to deploy these kind of one single rack of drives, for example. Just for clarity, the retrieval market kind of operates off-chain, so you can use the blockchain to set up a bunch of the transactions and to lean on payment channels or identities for providers and so on. But all of this operation has to work off-chain, and you have to get delivery to be extremely fast and with very low onboarding costs. So you can't create a structure where like the end users and consumers of some content have to have some like onboarding hurdles that prevent them from accessing the content. So I think those kinds of approaches will be harder to make work. Very possible, but harder to make work. And one of the images that I want to kind of leave everyone with is like really try to solve the kind of speed of light problem. So a key component in all approaches has to be how to reason about how the requests are coming into the various machines and route those requests to machines that are close to where the users are, and try to push content as close as you can to where it's being requested a lot. So over time, over the long periods of time, you can gain predictability over what kind of content gets requested where and so on, or have an adaptive network that over time moves the content to the right spots. This is how modern CDNs work. But decentralized networks and peer-to-peer networks and blockchain networks especially don't pay close attention to the hops going around and where people are kind of requesting things from and so on. And this is not something that retrieval markets can, that's not a luxury we can take here. We have to be very, very precise with which machines every single request is going to go to try and shave off tens of milliseconds at a time. That's how you get to extremely fast retrieval. So if your approach, as you're thinking about it, has any kind of open-endedness where a user request might accidentally hop across an ocean, that's not a good approach. Redesign. Like, really, you want to be extremely careful to make sure that users are able to kind of plot their retrieval pathway to nodes that are going to ideally have the content, ideally in their closest data center possible. Now, of course, that won't always be the case. You want to kind of like fall back gracefully, but you want to kind of exploit the landscape here to minimize the speed of light distance and minimize any kind of round trip and so on. Also important here, any kind of protocol that requires full round trips to operate, also problematic. You want to get to a spot where, as the round trip is as the request is going out, you can get the data back and be very, very careful about round trips. You can afford round trips when you're going close. So for example, you can afford round trips when a client is talking to another node 5 or 10 milliseconds away. Like, that's not a big problem. A round trip there is OK. But if you're dealing with round trips with hundreds of milliseconds, your host, do not do that. So that means, like, be careful in the choice of crypto, in the crypto handshake and establishment of encryption and so on, because usually those protocols introduce a bunch of round trips, and like they kill you. They kill your retrievability. So lean on things like noise and so on, and lean on routing end user clients to nodes very close to them, and then from there proxy over the request over an already set up channel to be able to kind of minimize the setup latency. So modern CDNs like Netflix and others, for example, have these like persistent connections where your client, when it wakes up, immediately connects to a set of nodes that are very close to them, does the connection setup, and from there reuse that channel to not have any kind of like additional setup times for any further requests. You want to exploit these kinds of techniques to avoid putting users in a position where like they're routing around and talking to dozens or hundreds of machines, and each time setting up new crypto handshakes. Like, that will totally kill any kind of retrievability speed. So here we want to kind of shave the latency down as much as possible and get to, again, tens of milliseconds in the best case, hundreds of 100 or 200, maybe 300 milliseconds in the kind of like average bad case. And of course, in the worst case, when the content is not hot or something like that, then you get into 1 to 5 second retrieval or something like that. But that should be very much the exception, and for very, very few cases. So this is non-trivial, right? So like doing this really well is hard, and doing this in peer-to-peer decentralized networks is way harder because most approaches are totally ignore speed of light, totally ignore reuse of connections, totally ignore crypto handshakes, and they just sort of assume that you have the capability of connecting to a ton of nodes in the network, and that you're, for privacy or security reasons, you're fine with that. In reality, the modern web and all video viewing will not move over to decentralized networks if that's how we operate. We have to totally shift the behavior here so that end user clients spend as little time in connection setup, and then from there can make extremely fast requests. So again, latency in the kind of like best case, we need to make 1 to 10 millisecond retrievals possible, and kind of get the norm to be kind of 50 to 500 milliseconds. Also, something that complicates this, the number of objects is very large. When you think about hundreds of petabytes of content, those hundreds of petabytes will have tons of little pieces of data, little files, little data structures, and so on. So you have a lot of objects that people want random access to. So you need to be able to do routing towards these objects quickly. You can exploit all kinds of things there to be able to amortize the lookup costs or do predictive lookups and so on. It's a whole other problem for another time. At the end of the day, we, again, kind of want to have, you need to have a network that has hundreds of thousands to tens of millions of nodes. Like that's kind of the where we're headed. I won't go into detail here. This is kind of well covered in a bunch of the other videos and so on. There's a lot of great tools and tech at our disposal. There's all kind of components that a lot of us have been building for 5 to 8 years now. And there's this broader approach that we're taking of really tuning for typical CDN product experience and aiming to build a profitable and easy to run retrieval provider software and aiming to kind of wire those components into really good products. Cool. So I'm going to give you some rapid fire updates from some other groups. And then we're going to kind of talk a bit about landscape. Although I'm looking at time, I may. OK, cool. Thank you. Thanks for the extra time. So this is kind of a map of the Filecoin ecosystem right now. Sort of made this relatively recently, or the Filecoin broader kind of data system. The ecosystem is larger and includes a lot of other participants and so on. This is kind of like a zoomed in view to the data flow. So think of kind of the data starting with the storage clients. That data is usually kind of associated with some use case or some pattern. And the end users of that use case, or the developers of that use case, will want to tune the access pattern and will want to tune the onboarding flow and so on to that particular type of data and so on. So that means that these sort of data on-ramps become extremely useful. These are services like NFT storage, Web3 storage, Estuary, Fission, Fleek, and so on. You can think of those as use case-specific applications that tune the interface and tune the parameter space to fit the data access patterns for that particular type of data. So you can think of like the interfaces that Filecoin provides as lower level infrastructure, or lower level plumbing, and you can think of the developer on-ramps and so on as a specific kind of like use case porcelain tuned to a particular data flow. So that's working super well, and each of these on-ramps is scaling significantly, and a ton of usage is coming in through those systems, so we'll see it in a moment. That and kind of like the data onboarding pipeline is very large already and growing, so I think we'll see it in a graph in a moment, but we have days where like more than 1 petabyte of new data is added in that day, and the average is around somewhere between kind of around half a petabyte a day, which is enormous. For context, the rest of the Web3 space is kind of like somewhere between 2 and 5 petabytes. So like we're adding way more content to Filecoin in 1 week than the rest of the Web3 world has in total. And that means there's all kinds of users coming from Web2 and from other more traditional approaches that are starting to use Filecoin. Now, that data today is not retrievable quickly. It's pretty slow and spotty and so on, as we saw in the last talk. One key piece that was missing was the ability to do indexing. So SPs were not advertising all their content into the IPFS DHT because that would be horrendously slow and a huge burden. And a new network indexer has been deployed in the last few weeks. And that indexing service now can index all the content from the various storage providers. So just right now, something that wasn't possible a few weeks ago is that now retrieval networks can lean on that indexer to find any and all of the content stored on Filecoin. So great opportunity to then create these kind of retrieval provider networks that can take a user retrieval request, look up in the index quickly, kind of like in an O of 1 access pattern, where to go get it, go get the content, and now provide it to the user. So we're now kind of finally in that spot. And so the dev on-ramps are working really well. Now what's not working well yet is the retrieval provider networks. We need to greatly improve that. The one that's most used today, you can think of the IPFS gateway and the IPFS spinning services as the kind of like best retrieval networks today. And we want to do way better than those. So we'll zoom into this model a little bit more later. For context, the number of SPs globally is scaling. There's growth in a ton of places in the ecosystem. This is kind of like a chart of like Filecoin Plus, which has been extremely useful in scaling up data usage and so on. You can see the graph in the bottom right of the amount of data being committed daily to the network. The y-axis is in terabytes, so like the top is like 1.2 petabytes. And that, that continuing, all of that data needs fast retrieval. So as I'll cover some use cases in a moment, and all of those are hurting for fast retrieval. So NFT storage, has on the order of like, it's about to cross 60 million NFTs, which is huge. It's a ton of individual objects. People want really fast access to those NFTs. And good news, they're not that large. When you think of all of those put together, it's not actually that big of a data set. So that could be replicated in a ton of places and served very quickly to end users. Web3 storage is a similar kind of developer on-ramp that also has a ton of data flow is growing at similar scale to NFT storage. And all of those objects need random access. You can think of like other large-scale clients and onboarding funnel. There's a ton of different groups that are in some stage of a trial of Filecoin. Like some users are early, they're finding out about it, and so on. Others are kind of running proofs of concepts at the moment. And in all of those conversations, retrieval becomes a big point. And so there's a ton of providers that want to make sure that they can retrieve their data and so on. The access patterns will vary. So some of these are large data users that when they retrieve something, they'll want terabytes. Like they have their own local operations. They're using these networks for archival or long-term storage or resilient storage. And when they retrieve something, they might want full terabyte drives to be sent to them and so on. Though that's not the norm. The norm is that people do want kind of random access to their objects. It just depends on what object size. In some cases, they're small, like kilobytes to megabytes. In other cases, they're like gigabytes. So think of video storage users as wanting access to many gigabyte files at a time. So again, NFTs are growing a ton. Metaverse and games is a big one. These are very much rate limited by retrieval. Mona is a great example. They're a platform that enables anybody to make metaverse rooms and whole spaces, and then sell them as NFTs, and then wire them up together so you can explore, go into one room and jump into another, and so on. Each one of these objects is gigabytes in size. So when you, especially the higher quality ones that sell more because they're like much more beautiful, are way bigger. So like the textures are pretty big and so on. Plus then all kinds of techniques that you might use to kind of do faster loading in the client side blow up the data size. So if you want to do like careful texture resizing and so on, you end up with like a larger overall size of an asset. So this needs really fast retrieval for the end users, especially if you think of like exploring a space that has a lot of links to many other rooms, and you have to sort of preload the other spaces so that when you walk around a corner and you enter another space, that other space has now been loaded and can be stitched together cleanly. Right now, if you hop into a Mona room, you're hit with a progress bar where like the majority of the weight there is loading, just downloading the thing. So that's kind of like a very concrete problem to solve. And there's going to be a bunch of other new kinds of NFTs emerging. So I think video NFTs are around the corner. They also need really fast retrieval. Videocoin, now called, I think, Vivid, and Livepeer are going deeply into this. Those tools just got deployed in the last quarter or two, and they'll follow a pretty fast growth rate. I would expect that within 2 to 3 quarters, we have millions of those. And they'll need really fast retrieval. And then there'll be other kinds of NFTs that emerge too. So when you think of like spaces like these, think of being able to create full experiences within those environments. It's not just a space. You can like program the space to have a game or have some other kind of artistic experience. And that kind of stuff is probably maybe 3 to 4 quarters out. So I would expect like next year to see a lot of kind of like the combination of 3D spaces and art, where you have like full experiences being developed and sold as NFTs, and those will need super fast retrieval. So a ton of opportunity. Just in general media and so on, of course, like video and audio are huge. the vast majority of the internet traffic on the network is video, on the broader internet, I mean. And so being able to tune the retrieval market to serve video extremely well and better than other networks, faster than other networks, and so on, is like a really, really great direction. So I'd sort of expect some of the retrieval market networks to evolve into a spot where they can deliver this video extremely quickly. There are other uses which have a lot less data but require a lot more random access. So things like individual, personal file storage, and so on. There are a lot of these systems already, and there are some set of storage retrieval networks are going to tune for these. The benefit of these ones is that it's not that much data. The files are really small, and you can cache them everywhere. But it just sort of tunes your approach to deciding where to put stuff and so on. Because here, like, you have like a very long tail of files that you access very rarely. But when a user wants to access them, they want them very quickly, right? Like you jump into like your personal file storage thing or your team's file storage thing, and you want to be able to search for a specific file, and you want that file to come up in ideally less than a second. But it's very long tail of files, and it's very hard to predict exactly which files will be used. And then there's a whole bunch of other really cool data sets that people are putting on Filecoin already. Large-scale data archives, including things like the Internet Archive, where the Internet Archive itself is like doing a pilot of putting a large chunk of data into the Filecoin network. But imagine being able to, we can actually host the entire archive many times over. The whole Internet Archive is, I think, on the order of like 60 petabytes or so. So you can like have that many times over and be able to provide fast retrieval to all of it. There's all kinds of other large-scale data sets and so on that are going to come in time. One opportunity for retrieval markets here is that there are several browsers that now have IPFS support. So Brave ships with a full, Brave works with like a full embedded Go IPFS node. There are others like Opera and so on that have kind of gateway usage. Those are prime candidates for Filecoin retrieval markets because, especially something like Brave with BAT, you can hook up the user's BAT wallet to pay for the retrieval of the content directly, and like that would actually close the loop and do kind of like the old, even 1960s vision of hypertext, where like the actual user is paying for the retrieval of the data as they're viewing it, and that would be pretty cool. But again, anything that sort of like requires user onboarding on a per page basis won't work. This has to be completely automated underneath the hood from the users, like BAT wallet, automatic swaps with DeFi, and then paying for the retrieval. Yeah, here's like a view into the network indexer project. I think this blog post was last week, so you can go check it out. And that kind of like really closes this really important loop here of being able to kind of index all of the content to be able to retrieve it quickly. The last thing I'll mention is FVM. So FVMs are around the corner. This will add smart contract computation to the Filecoin network, which will bring a ton of smart contracts into it and so on. All of those will need, a lot of those need access to data. And they will also create the opportunity for compute over data, which is a whole other set of things, which is you're able to kind of orchestrate and organize large-scale computational pipelines around the data on Filecoin. So think of large data having gravity. You bring the data onto Filecoin, think of large-scale data sets and so on. Then you want to run computation over that data. So you want to ship the computation to wherever that data is. That's less of a use case for retrieval, because in that case, you're trying to move the computation to the data. But that is likely to generate a bunch of results that are way smaller than the original data that do need very fast retrieval. So that'll likely generate, all the compute over data stuff will likely generate all kinds of intermediary artifacts that need to be retrieved quickly. Great. So so that's kind of like an update view across the whole network. So let's now kind of talk a bit about the retrieval landscape in 2022. So going back to this model, we need to boot up these retrieval market networks that try to localize regions to fight the speed of light. So the way I sort of think about it is like being able to create a bunch of different small subnets mapped to a specific region, and the size of this region, we can sort of start up with the region size that the cloud, centralized cloud has built, which is kind of like somewhere on the order of 5 to 20 regions in the world, and then subdivide from there as we need. And we kind of want to lean into leveraging the fact that there's two basic problems. One problem is how do you deal with the massive amount of requests that are going to come from retrieval clients? So how do you deal with the tons of connections and initial connection setup, which introduces latency and so on, and deal with that level of bandwidth and provide good user experience, especially to phones that you want to have really, really fast access, and you don't want the phone to do a lot of stuff. And then on the other side, how do you do the routing of the request to find where it is and fetch the data and ideally preload it into a region? So think of it like solving two problems. One problem is how do you handle the bandwidth and the large scale of the connections? And then how do you either preload or go find and cache the data quickly to kind of serve it from within that region? And I think that sets it up well for Saturn, because I think Saturn will talk about this. The broader picture, though, is like there are many different use cases and several different economic models. And because of these use cases and economic models, this will necessarily mean that there will be different retrieval networks with taking different approaches. And that means like different software distributions, different content, all that kind of stuff. We want to create an environment that enables those different retrieval networks to boot up, run, and so on, and interop as much as possible. And if we can lean on kind of payment channels and so on, and a very common interface on how to retrieve something, that could actually even allow interop between these networks. That I sort of see that as like a maybe late this year or probably next year type of problem. Let's first kind of work on booting up these networks to get to serving the kind of most common 1 to 10 petabytes of content around the world, around the network, and preload that into everywhere around the world to then be able to serve that extremely quickly, and create the networks that enable onboarding of a lot of people in those regions to be able to provide nodes to be able to serve in those areas. Cool. I will stop here. Any questions, thoughts? Yep.
Has PL spoken to the Internet Archive to explore, the big loud talking stick. Has PL spoken with the Internet Archive at all to explore accelerating the Internet Archive with any of the retrieval market products? Is that something that's been
So I think
explored?
right now they're working on a pilot to store the archive. Retrieval right now in Filecoin is slower than the Internet Archive, so once we have faster retrieval, then we can do that. But build the tech first, then do it. Yeah, but yeah, that's a very good data set. And there are on the order of 50 to 100 other data sets that are in various stages of like being identified or contacted or already in proof of concept, onboarding onto the network that need that kind of accelerated retrieval. So yeah.
Just curious, you talked about mobile CDN being like a much harder problem to solve. Mm-hmm. Could you like just briefly explain why that is and like how you would kind of start transitioning over to something like that in the future?
Yeah, so the reason why mobile is harder is that these are much smaller devices. The type of connection changes a lot. So for example, the profile of a mobile phone is very different when it's at home, plugged in a Wi-Fi network, plugged into the wall. So that means like it has reliable power and reliable internet, and probably not a bunch of use from the human because the human's probably asleep. So then at that point, like the mobile phone is good, but that usually is at night when other people around are probably not using the internet very much, and so other people elsewhere in the world might be using it. You also have like if you now deal with mobile phones when they're in your pocket and you're moving around and so on, now you're dealing with like connection changing because you're going across Wi-Fi networks to mobile networks, mobile internet networks, and so on, which means like a bunch of like connection tear down and reset up, and the phone itself, depending on the carrier, may or may not be getting a different IP, which for overlay networks and peer-to-peer, like that's really hard. So you deal with like, so you have like these massive networks with like nodes with tons of churn, so they're coming in and out all the time. They're not that big. You can't put that much storage in them relative to a home computer or something like that. And the internet and the bandwidth is not as good as some home bandwidth. And it's also very expensive. Like if people sort of like screw up their setup, they might be like charged tons of money for serving this. So it's just like a much harder product landscape. And so I would say, like, get it working really well first with home desktop type computers and with like data center small like single server machines. When you put like a ton of drives in like one server or a few, and like that's kind of like the best candidate target for Retrieval Markets today. That's easiest. Get that working, then from there you can then solve the hard problems of the mobile network. That's my guess though. It could be that someone like focuses on those problems really well, finds a narrow use case. Maybe it only works when you plug it in. Maybe it only works when you go to sleep, you open an app, plug it in, and like leave, and then maybe it works. But like again, I think you'll get more storage and better internet access from these other kind of like dedicated machines. Yep.
Just sort of adding on to that, because you also mentioned Netflix. I was wondering if you could add more color to how Netflix and or YouTube manages mobile CDN, if you had any insight there.
Yeah. Let me find. Is this it? So the kind of like perspective is that this is sort of like a map of the internet, and so you have this grapevine behavior. It's not very easy to look at it here. Maybe these diagrams are better. Like this is like a map of the internet. You zoom in. This is sort of like what the grapevine looks like. Here's another way to look at it. So you really want the content distribution to travel as few hops as possible, but you can't move all the content that's in like that densely connected interior out into the edges. So you kind of want to be adaptive. And so then the way that Netflix does it is that they're kind of like in the content provider spot over here, and then their users are consumers in homes or offices, and that path is really expensive for them. And so what they ended up doing was for a long time they shipped racks of drives to ISPs. I'm not sure if they're still doing this, but they preloaded these machines. This is part of the reason I knew that things like IPFS with content addressing and things like Filecoin were gonna work is because companies like Netflix do this. They would identify which movies were the most likely to be watched in a specific area, and they would then preload them into drives and ship that, and then do kind of in the background updates to those machines asynchronously from like the user's perspective. This would be kind of like a background process, updating the catalog in here. And then these machines would be sitting right there in the ISP, very close to the home users. So that becomes like a super fast hop, right? Like that becomes kind of 4 to 20 millisecond round trip, and like that's phenomenal. And there's a set of great talks from the Netflix team talking about kind of various different things that they've done to their architecture. One of them, I know that even for like their APIs, they do this like, they don't want individual connections set up every time. And so that even for their APIs, they kind of have like this bastion node that your user, your consumer like connects to, and then from there, they send requests out, and all of those requests get proxied from that node out somewhere else. And that node is like, depending on their service, that might be close to the user, or that might be in a data center somewhere, but it kind of gives you kind of this much more stable look from the user, as opposed to getting a phone to kind of open tons of connections to different machines and so on. So they really kind of took an overlay network approach to this, where they kind of like set up a connection, maintain that connection, and push as much traffic as they can through that. And other important thing, Netflix very much separates the application stuff from the content. So the movies get distributed by a completely separate system than the static assets of the page. So like these static assets that are involved in the web apps or the movie catalogs and so on, all those little files get distributed by a different system than the movies themselves. Because it's just you end up with like different requirements, and so you want software that like is just tuned for the specific use case. Yep.
Is there anything working right now, or anyone working right now on like mobile apps that you just leave online while you sleep, which would be like awesome?
Yeah, I do think that this kind of thing exists. I haven't done a review of the app stores to find them, but I think somebody has done this. I don't think we've been the only, because I've discussed this with a few people. I don't think we've been the only people to kind of think about this, so I would bet that some exist. I know that some people in our network want to go do this. It's just they haven't gotten around to it.
So we talked about mobile, like cell phones, being a very like not optimal candidate for delivering data, and stations at home being very optimal. What about laptops, which also frequently change places, are switched on and off?
Yeah, I think laptops are also not great candidates for that reason. I think a laptop is probably better than a phone, so it would kind of, if I were to kind of change this diagram here, I would add a laptop and then a phone all the way to the left, and say that the best type of nodes for now are like these. Let me. This is kind of like the sweet spot of where you want to be. So the thing on the left is not a laptop; it's just like a home desktop, or like a NAS, like a network attached storage device. And those, I think, are like the ideal candidates because they usually have somewhere between half a terabyte to 10, 30 terabytes in the larger case. And then these other, then you have a lot of people who either in data centers or at home with fast connections deploy like little server racks, either kind of like a small system with somewhere between 10 to 100 terabytes, or some larger systems with full petabyte. So there's a lot of people out in the world that have that type of storage, and they're not using all of it. And so that's like perfect candidates to kind of preload tons of content in there and then serve it from there. You just have to kind of route the request to them well, which is kind of why the two-layer architecture, I think, works really well. You want to preload a bunch of content and have it cached there, and then kind of have a different set of nodes that are dealing with the bandwidth. Cool. All right, thank you very much. Sorry for going over.
Cool. Thanks, Juan. We've now got 25 minutes until we go more into the more engineering and architectural focused stuff on Saturn. So if you're on the live stream, again, get a drink and get ready for the next part of this workshop. And yeah, back in 25 minutes. Hey, welcome back to the Retrieval Markets Workshop, an intro to Saturn. We've had the first half where we've talked more generally about retrieval markets, and now we're going to zoom in a bit more on Saturn. Our first speaker is the author of popular open source libraries Furl, Ice Cream, and ImmortalDB, and founder of Arc, a browser P2P CDN with 100 million users. He is also a great user of the English language, uses more words than I think anyone I've ever met, and a voracious eater of all cuisines, and eats more than anyone I've ever met. Once you meet him once, you don't forget about it. It's Ansgar speaking about Saturn.
Well, thank you, Patrick, for the splendiferous introduction. Good afternoon, ladies and gentlemen. Hello from beautiful Amsterdam. I'm Ansgar Grunzide. Today, we are going to take a journey together into the solar system. And not just to any planet, but everyone's favorite planet, and soon to be the world's most favorite planet, Saturn. So what we're going to discuss today in this talk is a new effort to build the world's best CDN we call Saturn. And it's not just any kind of CDN, it's a Web3 CDN. And what we're going to go through is we're going to talk about what a CDN is, why they exist, and where there is this momentous opportunity to redesign and rebuild what a CDN is using all the new primitives and tech that we have that Web3 brings. So with that, please, if any of you guys have any questions, please jump in as we jump into this together. So, what is a CDN? CDN stands for a Content Delivery Network. And if you look on the left diagram, let's look at what the world looks like without a CDN. When you open your browser, your desktop browser, your mobile browser, or any device and load a website or access any server online, your device, your browser, connects with a server somewhere else out on the internet. And this is generally like a point-to-point connection. So let's go through an example. Let's say you load an image on Instagram. In the model of the world without a content delivery network, you as a user and your phone would connect with an Instagram server somewhere else in the world. And this is likely going to be one place. And what happens is now, as we scale Instagram from 1 user to 10 users to 10 million users to 100 million users and 1 billion users and beyond, if we have one kind of centralized location where all the images and all the Instagram data exist, it becomes inundated. And these servers will literally melt under load. And this comes in, or where this comes in, is the birth of the CDN. So the very first CDN, the progenitor of CDNs, was Akamai, built by a bunch of MIT grads in the early 2000s. And the problem they set out to solve is how do you scale a service like Instagram, where if you have 1 billion users all around the world and they're all trying to access the same content, they can't all hit the same services, or the same servers. Those servers can't scale. It's imagine like you, if you're the server, trying to hold a conversation with one person, that's doable, 2 or 3 people, that's doable. All of a sudden, you're trying to hold a conversation with 1 billion people, you can't do it. Same thing with a server. They can't scale that much. So the problem that Akamai and other early CDNs set out to solve is what can we distribute in scale to power a website? So when you access a website, that website is comprised of many things. It's comprised of text, it's comprised of images, video, elements like that. And the biggest and heaviest images and assets are actually retrieved in the same manner by everybody. So if you go to Instagram and you link someone an Instagram post, they're going to see the same picture that you see. And that same data is going to flow to them as it flowed to you. And so Akamai and these CDNs realized this, and they said, wait a second, what if we can take that image that everyone is loading and distribute it globally? So instead of that one image being stored on the one Instagram server, what if we copy it and we place it all over the world in thousands of servers close to end users? And then when I load the Instagram page, I will load that image from a server close to me. And when someone else in India or Chile loads that image, they'll load the same image, but from a much closer copy and a server closer to them. And that is really the whole idea of a CDN, is you take what's static and you distribute it and scale it globally such that the original servers don't melt and you can grow the service to a larger degree than previously possible. And the key piece here is you improve performance. The closer an end user is to the server they retrieve content, the faster and cheaper it is to retrieve. So that's the genesis story of the very first CDNs. They came about to help scale web services as they grew quickly and improve the performance thereof. Now, this brings us to the present day. What the hell is a Web3 CDN? There are lots of Web2 CDNs. Ones you may have heard of might include the original Akamai still around or Cloudflare. And now we have an opportunity to build a Web3 CDN. What a Web3 CDN entails is it's a CDN, just like the prior generation of CDN, where you take caches of content and you push it close to end users for performance and scalability. But you take and push that content close to end users using Web3 primitives and crypto incentives. And as we're going to explore in this talk, with these primitives, these unlock new and larger networks. The network we're talking about, Saturn, has the potential to be the largest distribution network of content in human history. And we're going to get there, and we're going to get through why. Now, why are we starting to build this? Where do we see this opportunity? Well, there's a huge opportunity with Filecoin's network specifically, where Filecoin has assembled a massive storage network of 16 exabytes and rising, but it's really locked. If you store data in Filecoin, it's not easy to retrieve. It's more like this Facebook model where it's all stored on a few centralized servers. What we can do with the Retrieval Market, and Saturn specifically, is take all the data that's stored in Filecoin and distribute it globally so that it's fast and cheap to access everywhere. And most importantly, we can do this and take advantage of market dynamics, where all CDNs, that existed prior, Web2 CDNs, they grow as like a centrally managed organism grows. Somebody in a boardroom in a business room wearing a suit somewhere gets out their checkbook and says, we need to build another data center here, and they go and build that data center. That's a completely old-fashioned and different model than the model we're bringing with Web3, where it's more like a dynamic market, a marketplace, where there's supply and demand, where the market can see there's an opportunity for new servers to be added, let's say in Mumbai, and that market opportunity is recognized by someone who has servers in Mumbai, and they can connect them and join the greater network. And there was no central coordination here. No one had to ask a company, do I have permission to plug my servers in and make Saturn a better network? They just did it, and they rewarded in kind. So how are we going to go about building this? Let's zoom back in now. So we kind of covered what a CDN is and some of the Web3 primitives we're going to use to build Saturn. How are we going to go building it? Well, one of the key pieces here is when you don't have a central organization running everything and you allow anyone to jump in, you need to build trustless, permissionless systems. And this is a key piece, because if anyone can plug their servers in, that server operator in Mumbai plugs his servers in, who's to say that either through malice or incompetence, he's going to screw something up? You request cat.ping, your favorite kitty picture, and you get back dog.ping, someone else's favorite dog picture. We need to forfend against that kind of attack or network failure. And the other key piece here is the scalability of a decentralized network. So again, with all the Web2 CDNs, there is one company and one brain, or one set of brains, thinking about how and where their network should grow. We want to race past that. We want to change the game here, where in a decentralized manner, anyone can see these opportunities and plug in. And there's some other key tenets here. All of our work is open source and will be open source. Anyone can jump in, anyone can work on it, and we welcome that, and the whole network can improve. And the last piece here is, why should you participate? And the answer is, you can be rewarded. If you have spare capacity, you can add that to the network and reap the rewards. You can improve other people's experience online and make the internet faster and receive rewards in turn. And that's a completely different model than every other CDN that's been built. Now, let's jump into some of the technical pieces here of how we're building Saturn. So as I mentioned before, one of the key facets of Saturn is that it's trustless, which means anyone can plug their infrastructure into the network and start serving requests to end users and making their experience faster. But you run into this problem of, again, what happens if you request your favorite kitty picture and you get back your favorite dog picture? Well, we lean into content addressing with SIDS here to solve this problem. And how does this work? When you request a file, you don't actually request cat.ping. You request the content ID or the SID of that file. And the SID of that file contains the hash or unique ID of that file. And then what the server responds to you with is not actually just the raw bytes of the file, but it's what's known as a car file, which is a package of that file along with a bunch of hashes of all the data therein.
in a manner where the end user can verify that content, that it's the content it requested as it's being received. So what we call this is incremental verification. And this means, let's say you start watching a YouTube video, and the YouTube video is 2 minutes long. As you start watching that YouTube video, and some person, you have no idea who it is, and their servers are sending you that YouTube video, you know the content ID of that YouTube video, and you know how to verify that YouTube video as you receive it. So as they send it to you, you're incrementally verifying that every frame as is rendered in your browser is the right frame, and not necessarily like a random dog picture as one of the frames. And this is fundamentally new. There are no CDNs that do this. Every CDN you use currently, you have to trust the other party to send you the information you request. So building this incremental verification with car files and content addressing lets us achieve a trustless network. The other piece that we want to achieve with Saturn is to build an inclusive network where anyone can plug in all manner of hardware to the network and receive rewards. So if you own a bunch of large capacity servers that have tons and tons of hard drive space, you can become a large cache for other users on the network. If you plug in a smaller server connected to much faster bandwidth, you could be an endpoint that many users connect to and you serve as like a hot cache for those users. Or if you're just on your local desktop machine, you could install a Saturn desktop app and bring your storage to the network when you're online in a manner that you want and you're fully in control over, and you also receive rewards. And in the future, we would love to unite browsers together too. So even without having to install anything, you could contribute to the network and receive content from the network in a peer-to-peer, browser peer-to-peer manner. And the reason we want to do this is imagine Airbnb. One of the reasons that Airbnb has been so successful is they didn't just focus on large mansions. They didn't focus on beachside resorts. They let the world add all of this capacity from small houses and all the way up to full-scale castles and connected them with an audience, customers that want to stay in those locations. And we want to do the same with hardware that you can connect to Saturn. So you can connect anything you have and supply the capacity, and the network will figure out how best to leverage that capacity and in turn how best for you to be rewarded for adding that capacity. And the last piece here is the crypto incentives. And this is the engine upon which Saturn will burn bright, where, again, going back to the prior example of Web3 CDNs, where they're centrally managed, what's different here when Saturn is decentralized and you plug in capacity to the network, you can join the network and earn Filecoin. And it's part of a supply and demand network. So if you kind of see this graph here on the left, this is actually from Helium's website, which I recommend everyone go to. It's absolutely fantastic. You can see a network map of Helium if you're familiar with Helium. But imagine the network kind of looks like this. This is something we'll build and we'll have readily available too, where you can see where there might be a lot of user requests flowing through the internet, and there's not a bunch of points of presence, a Saturn points of presence, or network capacity in a given location. And imagine there is the best Christmas present you've ever opened. It's just waiting for you to open it, and all you have to do is plug in some servers in that location and reap the rewards. And so in this manner, there's this dynamic supply and demand where the network scales itself. And again, as far as scaling and scaling speed, because it's permissionless, you don't need anyone's permission to add capacity. No one needs to sit there and say, yeah, you can add a server in Mumbai or you can't. You can add it to the network and get rewarded justly. So what we've covered so far is some of the high-level ideas of things that have changed and new technology we have to build a fundamentally different CDN. One that's trustless, where anyone can join the network and send content that's verifiable to end users. One that's permissionless, where you don't need anyone's permission to add your capacity to the network. One where you receive rewards no matter the device you have and no matter the capacity you have when you add it to the network. And this open source software that will tie it all together, and the crypto incentives that unite everyone into the same boat. So at a high level, that's what we want to accomplish with Saturn, is we want to build the world's largest distribution network in human history, the fastest and the cheapest, and that's how we're going to do it, is using these tech primitives. So if anyone has any questions, I have answers.
I can start us off.
Sure, Patrick.
From your experience building Arc and then starting off building Saturn, what would be your takeaways in building something which is essentially much more, there's much more power in the hands of the user and anyone can join the network? What are the sort of things you've learned from Arc which will come to Saturn?
That's a great question. The biggest takeaway the biggest lesson learned is one of scalability, which is that when you don't have to have some sort of centrally planned or centrally managed team that decides how and where the network grows, the network can grow much, much faster. And so we saw this with Arc, a giant browser peer-to-peer network. We were able to scale from 0 to 100 million nodes in our network in a little over a year, which is unprecedented. And one of the reasons we were able to do that is because no one was sitting there deciding who and where to add capacity. Again, there's no one with the decision responsibility of getting out their checkbook and writing a check to build a data center somewhere. The owner of that data center, the existing infrastructure there, can, of their own volition, decide to join the network. So I'd say that's the biggest takeaway. One, simply of scale and speed.
I've got some questions which have come in from someone who's watching on the live stream. 1 second. You mentioned that there's these L1 and L2 nodes in the network. Do you have off the top of your head the hardware requirements or the system spec for these two different levels of the network?
Yeah, that's a wonderful question. So what are the hardware requirements, kind of minimal hardware requirements to plug in hardware capacity to the network? We want to run the full gamut and support everything from laptops and desktops, supplying mostly hard drive capacity or cache capacity to the network, and kind of an L2, so not user-facing, where like a lot of end users won't be connecting to your desktop, but you might be an L2 cache layer to machines that are more user-facing. And so your hardware requirements for kind of an L2 cache machine would be your desktop, order of magnitude, hundreds of gigabytes to terabytes. And we also want to have other hardware, which is more user-facing, where you need much faster internet. Let's say like a gigabit per second connection, and anywhere from a few terabytes of cache attached, all the way up to a full rack of servers. So really anything in between.
Okay, great, thanks. And then another question is, I think that, I know there's a test network already, which has been spun up privately. When will the test network be readily available more widely, and when will people be able to join the network?
Another wonderful question. So right now, Saturn is in testing. It's not in production testing yet, but the tests are going splendiferously. And we don't have a specific time we can announce publicly yet of when you can get your hands around a Saturn node and download the software and run it on one of your servers or run it on one of your desktops. I'm afraid I don't have that yet, so keep your eyes out, and we'll be sure to let you know and be sure to announce the up-to-date timelines as we have them.
Great, and then the final question which came in from the live stream, which I think I might answer, which is just when will the reward model or reward structure for Saturn miners be released? And we're having a cryptoeconomic workshop after the live stream today, where we're going to be working on this further, and it'll be most likely in the second half of this year that we'll have something really concrete to share with people. Any other questions for Ansgar?
It's going to be a real question.
I'm ready for it, baby.
Yeah, so you mentioned, sorry, it's on. Yeah, incentives. So I would say, probably for a Web 2, the end user has really no incentive in terms of a CDN other than the service working, which is huge. In terms of Web 3, is that the same model, or are there incentives for Web 3 users around interacting with Saturn?
That's a great question. Two pieces, two answers. The first one is, in the future, we'd love to have the actual user become a part of the network and start sharing content back out. So in that model, which we're not at yet, but in that model, the user could also receive rewards for everything they share back with the network. So imagine kind of like BitTorrent or like Arc, where once you've downloaded a piece of content, you can begin seeding that and sharing that content out with others near you in the network. And in that model, when we cross that bridge, you will receive rewards for the sharing you've done with the network. That's one piece of it. The other piece of it is, imagine right now, when you access a website like YouTube, you don't pay anything in terms of like a monetary exchange. You don't open your wallet and pay YouTube 3 cents for every YouTube video you watch. YouTube monetizes you and then takes that money to pay for the CDN service. You as a user don't pay for the CDN. There is another model here where with Web3 and microtransactions, users could pay to download the content. So they themselves, the end user, pays. And in that manner, they could be incented and say, I will pay more for loading faster or more for better performance in that manner. They could be involved in this kind of, the protocol talking with the CDN. So we're not there yet either.
Yeah, so because in that mode, it's almost as if it's a Saturn browser.
Right.
As well, right? That the service runs through.
Exactly.
Right.
Exactly, okay. Right. So those are two kind of different answers to your question of where things could go. But the very first version of Saturn will be built for what how the market operates right now, which is websites like YouTube. They're the ones who are paying for content delivery. They're the ones buying CDN capacity, and the end users don't pay anything. So how that model will change in the future remains to be determined. But those are two potential ways it could, where the user would be part of the either earning rewards or paying.
I covered it a little bit in the talk earlier, but already Brave has BAT, and BAT has individual users earning for the attention that they're giving to various websites. You could imagine hooking up BAT with automatic DeFi swaps to Filecoin and paying for the retrieval live. So a user is viewing a page with Brave. Part of the BAT that they would be receiving for viewing that page would then go to the CDN that is delivering the content, and that would happen automatically. I think this sort of thing can only work if it's completely transparent from the user, and the user is not involved in individual transactions, because from a product experience, no one's gonna open a phone, try to load a page, and then start paying for something. They have to be able to receive the content right away. But if the browser does it for them automatically, then it could work. And so I think thinking of integrating with things like Brave or pushing the BAT model to many other browsers, I think could be pretty successful.
There are also some web APIs coming along, like web monetization, which want to allow browsers to pay with microtransactions. So to help facilitate this kind of model and other models.
Yeah, I mean, imagining something even worse than GDPR for clicking through on every website.
Yeah.
10 times worse.
Yeah.
10 times worse. Yeah, because it's money.
Yeah.
Oh, it was a non-comment. Okay. Yeah, sorry.
Great question, though, Craig. Great question.
Great answer.
I have a question too. I feel like I think it's great. I think there's lots of promise with Web3 CDNs, but I feel like after the presentation, I still don't have a very concrete grasp of what exactly Saturn is, and then how potentially differentiate from, let's say, Miles or the other, even Titan. Could you share a bit more light on that, please?
Yeah. So I'm not sure so much about Titan. I'm not too knowledgeable about Titan and Titan's effort. As far as Mael, they'll be here in 2 days, and I don't want to put too many words in their mouth. But one of the differences is that Mael wants to pursue is they want to have end users paying. So initially for Saturn, again, who's buying CDN capacity is the service provider, like Instagram or YouTube. They're paying for CDN. And Mael's model is one of the kind of the half of the answer with Craig's great question, which is Mael wants the Web3 world or was building towards a world where the user ends up paying. And so it's the same kind of set of opportunities or changes where a user now has to kind of have a wallet and be able to pay for content. Juan might be able to answer some of this better.
Yeah, I can give an answer to that as well. So in terms of how the value flows around, let's take the Web2 setup where content publishers, content providers, they pay cloud services to host files, host websites, and then accelerate content. And end users are essentially getting free retrievals. As we kind of spoke about in the break, it's not 100% free because there's this idea that then they'll purchase something if they're browsing a marketplace, they'll purchase something or they'll watch adverts. And there's sort of then a circular economic flow back to the content providers. However, when we try and map that in terms of in-band payments, it gets quite complex, and the number of attack vectors that the system is going to have to counter for just rises with every single different connection between these different nodes in the network. So what Mael focused in on, they said, okay, let's do what they called worse is better or less is more. And it's let's just focus on that one interaction between a client and a provider. and let's try and make sure that that is as secure and as efficient, performant as possible. And whether it's a free retrieval or a paid retrieval, they're just focusing on that one interaction. And the idea being that if they get that interaction right, then you can start to see other things emerge around that, and people can build from that module into kind of more complex network-wide interactions. However, what that means is that you do have to kind of not have free retrievals for loads and loads of clients, because then you're subject to these Sybil attacks where you can spin up loads of different clients and try and make all these retrievals and then try and convince the content provider that you've done all this retrievals, and they then need to pay for it all. So it does put an onus on the client to have to then pay for a transaction or just govern the whole transaction in the local part of the network. So yeah, it's in that way, again, it's more Web3 focused. It's just between you and me if we want to do a transaction, and no one else is measuring it or governing it or kind of deciding what the payouts are based on it. It's just that the transaction happened and that's that done. And that's where I think Saturn is different, because the premise there is that people want to retrieve for free into their browsers in the same way they do in Web 2, and therefore there has to be this economic flow from content providers in the end. And therefore, it kind of breaks the model that Mael going for of just focusing on that one transfer.
Yeah, I think that was a great summary. One thing I might add is the Mael POP structure might work between retrieval providers and themselves. So one, if you think back to the internet grapevine model, you could have a Mael POP that's very close to the users, paying for and retrieving data from another Mael POP that's further up in the grapevine to bring down data, and then eventually to a storage provider. So you could use the Mael POPs as like really good links in that grapevine layer to have the individual kind of pairwise transaction be accounted economically. And so that you can kind of build up really well. If you then figure out a way of getting Filecoin to the end users who are then paying for the content. And so there's probably a few approaches. One approach might be you can build products where you download and install a kind of a cache that makes your browsing go faster, and you might potentially pay for that. Or you can have the browser BAT model hook directly into Mael. And so you could have like BAT swapped for Filecoin and then going through the Mael network. I think in the Saturn case, it's the publisher will sign up to have some content accelerated. This maps closer to the traditional CDN model, where the content publisher is trying to accelerate some subset of content. They set up a relationship with Saturn, they pay Saturn, and then Saturn orchestrates the network to deliver that content quickly to the regions where that content is being retrieved from. And so it's two different adjacent tangential models that I think both can really work. There's probably other content models that are not yet explored well. I think we'll probably see a lot of experimentation across these, and over time we'll see kind of what happens in the inner parts of the network. My sense is that if we can have good interfaces, then all of these networks can interop and pay each other and so on. But I guess we're meant to figure out the interfaces there.
Great question.
Thinking about the answers.
Any more questions?
Yeah, I think part of what Zix was getting at is like, hey, that was a good overview. It was kind of like what Patrick and I talked about. But I think there's no like concrete sense of Saturn itself. It may be useful to give an example demo of like how Arc works today and how browsers, and just talk through like load an Arc page and then talk through like how browsers make those requests now, and that might help close some of the questions.
I worry going through Arc is the core of your question, let me not rephrase it. Would you mind expounding a bit on what you'd like to see explained as far as Saturn's architecture would go? Diego's going to cover that some in the next talk and go into a bit into the kind of network diagram of like multiple levels of the cache. And
yeah, sure. We can wait for the next talk, and then like what was getting at is like, oh yeah, I understand all the high level is pretty much similar across the board, and I want to understand like, oh, how like where's the current status of Saturn right now and our roadmap, go to market, and all that kind of stuff. But if you're covering the next talk, that's fine too.
Oh, great. Yeah, so not all that will be covered in Diego's next talk. So let's see, some technical architecture of how Saturn currently works, and this is already built and running, is so in the browser, there's a new API called the service worker, which is like a JavaScript context that runs beneath the parent page. And it has a superpower. And the superpower of the service worker is it can see and handle requests made by the parent page. So the way Saturn is going to integrate and grow with websites is we'll have people install Saturn, or website operators install Saturn Service Worker. And then what happens is when a user goes to a website that's running Saturn, the web page will load and the service worker will begin running beneath the page, and it will see requests being made by the parent page, like for cat.ping or dog.jpg, and it will see content address requests, like requests for SIDs. And then that's when the service worker spins into action, and it sees those requests, and instead of sending them to, for example, the origin server, that kind of one server that the website's running on, it sends them to Saturn's network. And so it then sends a request to Saturn's network saying, please give me this content behind this SID as quickly as possible. And then what happens is that request is routed via DNS to kind of the nearest point of presence of the Saturn network. And that would likely be someone who's plugged in a bunch of servers and capacity near you in the network running Saturn software. This will generally be what's known as like an L1, or what we're referring to as L1, kind of layer 1 in the cache. So these will be machines that have, likely running in a data center, that have a lot of upload capacity, uplink capacity, and large cache capacity. So you'd be routed via DNS to one of these. And then one of these essentially does what a traditional CDN node or point of presence will do. It will look for that item, that SID, in its cache. And if it has it, it will return the car file of that file to you. So instead of, rather than like the plain text of the file, it will return the car file to you. And on cache miss, it will go to like an L2, or another layer in the cache. This could be some of the desktop nodes, or some servers that might not necessarily have as fast upload, but a lot of disk capacity, kind of a second layer in the cache. And onwards, that cache lookup will cascade all the way to the service providers, who again, kind of the nexus, if you remember Juan's model, where that's where the kind of the last stop where the data is absolutely stored. And then it kind of, as the cache cascades back, it's cached everywhere in kind of like LRU manner. And then finally the car file, either on cache hit or cache miss, is streamed back to the browser. And the service worker does another cool thing, which is that the incremental verification. So as this file is coming back, the browser knows the SID that was requested, and it gets the car file, and it can verify the content it's receiving from that L1 point of presence that it was connected to over DNS as it's being received, and to verify it. And then the service worker hands the plain text file, kind of like unwraps the car file and hands the data back and streams it back to the browser in the parent page. And then the browser in the parent page will render that content. So we've talked through a lot now in a little technical detail, but that's kind of a network flow, if you will. Is that kind of what you were looking for? Then there was another question, which is also an astute question, which is kind of what is the go-to-market strategy of Saturn? And the go-to-market strategy here is to find out like what hot request loads there are in the existing IPFS network. So like what is currently being requested the most from the IPFS gateway, and Saturn will serve those faster than the IPFS gateway. We are going to begin like racing the IPFS gateway. And once we achieve like the flip where we are now faster than the IPFS gateway, that's when kind of Saturn, the wheels come off and we turn into the rocket ship. We want to grow and be part of every website on the planet, let anyone around the world participate. But that's kind of the first strategy. So there's already all these requests flowing into the IPFS network. They're currently landing at the IPFS gateway, and they're not being served as well as they can be. And Saturn is going to be there to serve them better than they currently are. So that's kind of the first step. Does that help?
Yes, thank you.
Sagacious questions, thank you. Yeah.
Learning new English words.
All right, any more questions? Cool, in which case, it's on to Diego. We'll be live in a couple of minutes with Diego's talk.
It's a, oh no, there we go. So level 1 nodes. What are level 1 nodes? They are the outermost nodes in Saturn. They have a per-region hubs. Think of North America, South America, Europe. They are accessed via GeoDNS, as Ansgar mentioned. They serve car files via HTTP2 with TLS using Nginx. Why change what's already working, right? And they fetch car files from level 2 or greater nodes on cache in case they don't have it like readily available. And in exchange for those retrievals, you earn Filecoin, right? Amazing. So in this diagram, we see the retrieval clients fetching through HTTP car files from the level 1 nodes, which in the V0 implementation, if they don't have it, they just go to the IPFS gateway. How does the sign-up happens? We'll go through that on the registration with the orchestrator, which uses Route 53 for the GeoDNS setup. It also contacts a log service to send how many retrievals have there been made for which CIDs and from which clients. And there's also the last part, which is the fraud detection. We don't want to pay you if you're faking those retrievals. So what goes inside a level 1 node? We have a big Docker image that runs Nginx and a Node.js process. This Node.js process pretty much handles the cache miss, which contacts level 2s. It has the log ingester, which consumes logs from Nginx in a specific format, and it just throws them to the log service. We also have the registration part, which pretty much allows to contact the orchestrator. Hey, I want to be part of the network. Set me up. Give me a TLS certificate, and join my IP to the DNS records in my region. There's the registration check. It's just a tiny endpoint, so that whenever there's a sign up, we want to make sure that you do own that gateway, that level 1 node, and that it matches. And there's a health check every minute. If you, for whatever reason, go offline, we'll remove you from the network and hopefully not affect any users. And there's reputation on that. The greater uptime you have, the more traffic you will get. And outside that Docker image, we have the auto updater, which will keep your Docker image up to update, and we'll check the registry for newer versions in an interval. So what's the setup like? We have hardware requirements for the level 1 nodes. You need a Linux server with a public IP. Ideally, you have 100 gigabits per second, but the minimum is going to be 100 megabytes. You have 2 gigabytes of RAM. That covers most of desktop servers, VPS, but 8 gigabytes or more are recommended. The minimum disk is going to be 128 gigabytes of SSD, but ideally you have a great setup of RAID 0 NVMe SSDs that are 2 terabytes or more. In the footnotes, you can see that the more you can serve, so the greater upload speed you have, the more Filecoin earnings you get. And the bigger disk, it means bigger cache. That also means greater Filecoin earnings. Some general requirements before you can even set up a node. You have to have a Filecoin wallet address and 10 minutes. And hopefully that will be like 1 minute in the future. So how does the registration happen? When you set up this Docker image, you bring it to your VPS, your dedicated server, your Raspberry Pi at home, and you say you want to become part of the network. So the initial steps, it pings the orchestrator, who will go back to you in the public IP that you're coming from and verify that you own that node ID, and will give you a token. You have to persist the TLS certificate that the orchestrator gives you on demand. You will join the geolocated DNS, so if you're coming from Florida, you are going to be serving requests in Florida. If there's no nodes in Georgia, for example, you're also going to be a point of presence for that traffic. Lastly, you will receive a token, so you can send the logs back to the log service. And you re-register every 5 minutes and have that token refreshed. In order to have smooth transitions or blips in the network, you should be doing a graceful registration as to not kill active requests. So there's a graceful registration process, which you let the orchestrator know that you are going offline for maintenance or just updating the Docker image itself. You leave the DNS for that region. You gracefully finish the active retrievals, and then you shut down. If you don't, then you have a hit in your reputation. So what are the responsibilities with the network of the level 1 nodes? The first is the registration, where you get the TLS certificate and the DNS setup, so you can start getting requests. There's a continued re-registration plus the health checks to verify that you're still online, you're still serving content, and answering those retrievals, which, as Ansgar mentioned, they are through CIDs. You want to maximize cached content. That means the greater Filecoin earnings. You have to fetch CIDs in case you don't have the content readily available from the level 2 or greater nodes. And you have to continuously verify all the blocks that are coming from those providers, because also you don't trust them. You have to report the retrievals to the log service. That's done on an interval of 5 minutes. And you also report the load and the bandwidth that you have. So you can either receive more requests or we send you less requests. And updating. The Docker image should be kept updated. If it goes out of date for more than 24 hours, you get removed from the network. And the TLS certificate is renewed every 85 days, just under the threshold of expiry. And earning, which is the most interesting thing. With the log ingestion, the Nginx logs are parsed, aggregated in batches, and sent to the log service using the token that the orchestrator has provided. And Filecoin will be delivered to your wallet address in a daily basis. We hope to be launching V0 soon in the test network that we have on testing, not production testing, but and mainnet hopefully coming in a few months. Thank you. Any questions?
Nice, thanks, Diego. Yeah, I've got one to start off with. You mentioned that the orchestrator is giving a TLS certificate to each of the L1 nodes.
That's correct.
Have you looked at any ideas about how the certificate management could be more decentralized?
We haven't yet. Right now, as everyone is joining pretty much the same DNS record, which is cdn.saturn.network, everyone has to have a verified TLS certificate. And sadly, that's not decentralized. Everyone could ping, for example, Let's Encrypt or such options. But then it would be much more slower. And the DNS verification of that part would not be able to be completely decentralized yet. We just haven't researched on that.
Nice, thanks. Yeah, any questions?
Yeah, on one of the first slides, where you have, I think it's the first one. Yeah, you're talking about car files there, that the car file gets requested from the client, right? What happens with these car files once they're sent back?
In the retrieval clients.
Yeah, yeah.
So retrieval clients start consuming the bytes and continuously verify all the blocks, which is one of the advantages of CIDs. And that's done on the service worker.
Okay, but normally the file that the client would request would be like a JPEG or whatever, or a video, which would be something completely else.
Yeah, so the service worker grabs that car file and pretty much unpacks it. While continuously verifying the blocks, it will then render the JPEG or PNG or the video that you have. Yeah.
All right, another question at the back.
Yeah, thanks. This talk is really useful. One question, I think the goal of using Nginx there as a cache layer is a really good idea. I was wondering if you could expand more as like the trade-offs there and so on. I think it's a very good design decision, and I think other people should hear about it.
Decisions that were made? Or?
Yeah, like just talk about like why Nginx. In that's a really good idea, but just kind of like help unpack for other folks watching.
Of course, so Nginx was chosen especially because it's a tested solution that's open source. And I've worked with it a lot through the years. That was my go-to. I guess we could go with Varnish or other solutions, but Nginx is proven and tested, battle tested across a lot of internet services. Anything else you would like for me to dive? Yeah. All right.
Any other questions?
Well, feel free to reach out to me on any social network or Diego at protocol.ai, and I will answer any questions that you might have.
Awesome. Thanks very much, Diego. And that's the end of the presentation, so that'll be the end of the live stream. And we'll have a quick break, and then we'll have a workshop mainly around the cryptoeconomics of retrieval for those who have joined us live. Thanks, guys.